I will be going into depth about the various elements of ATC routes. These include the two types of departure procedures, arrival procedures and their constraints, and instrument approach procedures. Let us begin with explaining the two types of DPs. The first DP is called an obstacle departure procedure, and this DP gives the pilot obstacle clearance to their appropriate en route structure. A ODP may be flown without ATC clearances unless ATC assigns you a specific radar vector or SID to follow. These DPs are either printed textually or graphically and can be found in the government procedures publications. The second DP to mention are standard departure procedures, SIDs. SIDs provide obstacle clearance as well as a transition from the terminal area to the appropriate en route structure. SIDs are used to reduce the workload of the pilot and the controller by providing an orderly traffic flow. A SID may be flown after ATC gives you a cleared as filed clearance if no other DP is assigned. SIDs are always shown graphically. After that brief overview of departure procedures, let's discuss the climb gradients for DPs. The standard rate for obstacle clearance is 200 feet per nautical mile. Always look at the notes on the DP plate to see if the climb gradient is non-standard. Since the ground speed varies for every plane, you will have to convert the feet per nautical mile to the feet per minute shown on your PFD. The conversion is actually very simple. First, divide your ground speed by 60, then multiply that number you got by the required feet per minute. For example, if your ground speed's 90 knots, dividing 90 by 60 gives you 1.5. Then multiply that 1.5 by the required feet per nautical mile. So if it was standard, then it would be 200 feet per nautical mile. So you would simply multiply 200 by 1.5, which would give you 350 feet per minute. Now let's move on to arrival procedures, aka STARS, Standard Terminal Arrival Route. STARS are basically a way for a pilot to get from the en route structure to the instrument approach. Similar to DPs, STARS simplify clearances since the details are published and ATC doesn't have to read them to you in a clearance. An important constraint of a standard terminal arrival route is that a pilot may not descend below their last assigned altitude unless they receive a clearance to descend via the altitudes in the STAR, receive approach clearance, or are on a published segment of that approach. Alright, finally, let's discuss instrument approach procedures. Basically, IAPs are used to help pilots in IFR conditions to descend down safely from their en route altitude and land on a specific runway, either by doing a straight in or circling to a different runway. Pilots use approach plates, which show a 3D picture of your path down to the runway. These approach plates contain a lot of information useful to the pilot in IFR conditions. Some particular information shown on approach plates include holding patterns, initial and final approach fix, missed approach point, as well as the missed approach procedure, all the frequencies that you would need for your comms and VOR, airport diagram, and much more. Although you might have the correct instrument approach plate, it might not be current since they are regularly revised and changes are available every 56 days. You can check the expiration date of an approach plate by looking on its side. As you can see, departure procedures, arrival procedures, and instrument approach procedures are very helpful resources a pilot can use to keep them and others safe. I hope my brief overview of the elements related to ATC routes given you a good perspective on the tools at your disposal in IFR flight and the importance of using them. Thank you.